Now say in addition to the damping, there is an external force applied to this vibrating spring, and in that case you can see that we will have that force add up here, and the differential equation will be, so the equation will become this, with the force function involved in here. So let's look at an example. So let us take an example of such a differential equation, that is differential equation with forcing. In this case, when it says a mass of one slug, so our m is 1, and it says when attached to a spring, it stretches it 2 feet and then comes to rest. So that will help us obtain k. And then it says that starting at t equals 0, an external force of 8 sine 4t is applied to the system, and we have to find equation of the motion if the surrounding medium offers damping force equal to 8 times the initial velocity. Alright, so for this, let's just substitute what we know, and then we shall determine the rest. So we know that the mass is 1 slug, so m is 1. K we will determine, and c is 8, and this external force is 8 times sine of 4t, right? Now to determine k, notice that mass of 1 slug, which will be 32 pounds of weight, alright, because that is g, so this is mg, and that has to equal k times how much? How many? 2 feet. So k will be 16 lb per, or pound over feet, right? Okay, so that's our k. So let's write k down here. Okay, so you have, or we have, k equals how much? K equals 16. So our differential equation becomes, okay, we will bring these this 8 dx dt on this side, okay, and then let's just remove these guys here, and this also to this side, and turning that into positive. Okay, so this is the differential equation that we are going to solve. Okay, so we have what do we have? Let's write our auxiliary equation here, okay, which is this equals 0, so which means that the equation for e to the mt, which we assume as our solution, would be this in our way of writing, which is m plus 4 square equals 0, right? So what happens here is negative 4 is a repeated root, so what we shall have is our complementary function is going to be simply c sub 1 e to the negative 4t, just because negative 4 from here is a repeated root, and since we have to get another linearly independent solution, we will have then t times e to the negative 4t here. Okay. Now to get the particular integral, notice that this suggests that our particular integral will be of the form a times cosine 4t, right? Then plus b times sine 4t, okay? And that, so we will just take the derivative and the second derivative and substitute that in the original differential equation, okay, to obtain that the yt prime is. When we differentiate cosine of 4t, what will we get by the chain rule? Negative 4 sine of 4t. And likewise, the derivative of sine of 4t would be 4 cosine of 4t, again by the application of chain rule. And when we go to obtain the second derivative, let's do that right here. Okay. And notice this, I have made a mistake in my notations. These should have been x's. I apologize. Just getting too late in the evening when I'm making this for you all. Okay, so this is x and this is an x. Okay, so I'm taking the second derivative here. So again, sine 4t, the derivative would be 4 cosine 4t, and I just multiplied that 4 with this 4. Likewise here, cosine 4t, the derivative would be negative 4 sine 4t. These two combine to 16. And here I have a sine, right? Okay, so what we have is, if now you know this, that if I replace these x's by xp, this equation should be satisfied. So just I'm just writing it to you just to reinforce that point. Okay, so if we write all these values, here is our x double prime, okay, plus we will have 8 times xp prime. Okay, let me just reduce the fonts just for a few minutes, then I'll bring it back for you. So then we have 8 times xp prime, which is right this here. Okay, and then plus 16 times our xp. Where is xp? Right here. Okay, and that equals how much? 8 sine 4t, right? So this should hopefully produce the values of a and b for us. So cosine 4t, let's just collect the like terms. So this is negative 16a. Then what else do we get as coefficient of cosine 4t? We get plus 32b, and then from here we get positive 16a times cosine 4t. Okay, then what do we get for the coefficient of sine? We get negative 16b from here, right? Okay, then we get positive negative 32a from right here. Okay, and then what do we get here? Plus 16b. Okay, and that's what? That's sine 4t, right? And here on the right hand side, what we got then is 8 sine 4t, right? Okay, one moment, I see a typo here. Okay, so that's what we got. Okay, so we can see this here, 32b cosine 4t. All right, because a's cancel here, then plus 32a, sorry about that, sine 4t. Let me just enlarge our fonts again. Okay, sine 4t, that equals 8 sine 4t. All right, so now just one moment, I made a mistake in copying here. Again, this should be negative 32a sine 4t. So what this gives us is that negative 32a is 8, which means that a is negative 1 over 4, right? And 32b is 0, which will give us that b is 0. So who is our particular integral then? Our particular integral is going to be b is 0. So that is simply going to be, this is out. All right, negative 1 over 4 cosine 4t, right? So what is our general solution then? Okay, our general solution is see here the complementary function, right, plus the particular integral. Okay, and now let's go back to the question, and I don't know why we didn't write the initial conditions before. Let's see if there is anything to give us the initial conditions. So sorry. So we have, so it is at rest in the equilibrium position. So that means that we may assume that x at 0, okay, all right, and is 0, and so is x prime at 0 is 0, okay, and you can just find it in the routine fashion. Go ahead and determine C1 and C2, and forgive me, I just is getting too late for me for certain things, so I'm just going to use the computer to get the values of C1 and C2, but it wouldn't take you too long to get those two values. So let me just use this particular package to obtain the solution for you. So we have our differential equation is d2x dt square, all right, plus 8 dx dt, okay, plus 16x equals 8 sine 4t, and these are our initial conditions. Now I'm wondering whether we could have gone ahead and do the algebra during this time, but that's okay. And let's ask it for the solution, and here is your solution. All right, I just pushed e to the 4t downstairs, so both these values C1 and C2 will be 1 each. Okay, all right, so let me just put that in the next line. So this is the solution, all right, or the equation of the motion. Okay.